Q11. You're analyzing customer data for a subscription service using a SQL-based analytics platform. One of the columns, member_ID, contains missing entries due to incomplete registrations. You need to write a SQL command that accurately returns a number of null values in the member_ID column to assess data quality. Which command should you use? A. Select count member_ID from my_table. B. Select count member_ID, count_null member_d from my_table. C. Select count_if member_ID is null from my_table. D. Select null member_ID from my_table. The correct option is C. Select count_if member_ID is null from my_table. Explanation: count_if condition is a highly efficient built-in function in Databricks SQL that returns a total count of rows for which the specified Boolean condition evaluates to true. By passing member_ID is null, it perfectly tallies up exactly how many rows contain missing registration entries. Alternatively, you could also write this using a standard conditional aggregation like SUM, case when member_ID is null, then 1 else 0 yandy. But count_if serves as a cleaner shortcut for exactly this use case. Why the other options are incorrect. A is incorrect. The standard count column_name function explicitly ignores null values and only counts rows that contain a valid, non-null value. This would give you the number of completed registrations, not the missing ones. B is incorrect. There is no standard Databricks SQL function called count_null. To find the null count using standard counts, you would have to subtract the non-null count from the total row count. Count asterisk, count member_ID. D is incorrect. There is no null function that aggregates or counts values in this manner. Q12. You're designing a multi-region data governance strategy for a cloud analytics platform using Databricks Unity Catalog. The architecture must comply with Unity Catalog's rules around metastores, managed locations, and catalog associations. You need to identify which conditions are valid for enforcing governance in Databricks Unity Catalog. Which two conditions are applicable? A. Set up more than one metastore in the Databricks account console, ensuring only one exists per region. B. Assign managed location to both catalog and schema when a Unity catalog metastore lacks an associated location. C. Define multiple catalogs within a single metastore and attempt to link one catalog to multiple metastores. D. Ensure that if the metastore has no associated location, the catalog must be configured with a managed location. The correct two options are A and B. Explanation of valid conditions. A is correct. Set up more than one metastore, ensuring only one exists per region in Unity Catalog's architecture. You can create multiple metastores within a single Databricks account console, but you are restricted to creating a maximum of one metastore per region. A workspace can only be attached to one metastore at a time. B is correct. Assign managed location to both catalog and schema when a Unity Catalog metastore lacks an associated location. If a Unity Catalog metastore is created without a root managed storage location, you must explicitly provision storage lower in the hierarchy. You can assign a managed storage location at the catalog level, the schema level, or both to ensure managed tables have a designated path to write data. Why the other options are incorrect. C is incorrect. While you can easily define multiple catalogs within a single metastore, a single catalog cannot be linked to multiple metastores. The hierarchy is strictly top-down $account /right arrow metastore /right arrow catalog /right arrow schema /right arrow table $. D is incorrect. If the metastore lacks an associated location, the catalog itself does not strictly have to be configured with managed location. The managed location can instead be defined further down at the individual schema level. Q13. A data analysis team is experiencing slow performance when running multiple Databricks SQL queries through a shared SQL endpoint. The queries are small, but many users execute them at the same time. The data engineering team investigates and finds that the current SQL endpoint scaling range may be limiting available compute during peak usage. What approach can the data engineering team use to improve the latency of the teams? Queries? A. Increase the SQL endpoint's cluster size to allocate more fixed compute resources. B. Adjust the SQL endpoint scaling range by raising its maximum limit to support higher concurrency. C. Enable auto-stop on the SQL endpoint to shut it down during idle periods. D. Activate the serverless feature on the SQL endpoint to allow dynamic resource provisioning. 4. The correct option is B. Adjust the SQL endpoint scaling range by raising its maximum limit to support higher concurrency. Explanation. The team is experiencing a concurrency bottleneck, many users executing small queries simultaneously. In Databricks SQL, adjusting the scaling range, multi-cluster scaling, allows the SQL warehouse, formerly endpoint, to automatically spin up additional clusters of the same size when query queuing occurs. By raising the maximum cluster limit in the scaling range, the warehouse can scale horizontally to handle peak, concurrent traffic, distributing the small queries across multiple parallel clusters and significantly improving latency. Why the other options are incorrect. A is incorrect. Increasing the cluster size, e.g., scaling up from small to medium, allocates larger virtual machines to a single cluster. This helps speed up massive, resource-heavy queries, but it does not add more clusters to handle high user concurrency for small queries. C is incorrect. Auto-stop is a cost-saving feature that turns off the SQL warehouse when no one is using it. It does nothing to help performance during peak operational hours. D is incorrect. While serverless SQL warehouses scale very quickly, simply activating a serverless feature does not automatically fix a concurrency bottleneck if the maximum scaling limits on that warehouse are still set too low to accommodate the active user base. Q14. You are an enterprise software engineer building a data processing application on your laptop using a local ID. After setting up Databricks Connect, you execute your PySpark scripts locally. You observe that heavy DataFrame transformations are processed on the remote compute resources, yet output commands such as .show print the evaluated records straight into your local terminal. What fundamental architectural concept does this workflow demonstrate regarding how Databricks Connect operates? A. It demands manual synchronization of the evaluated outputs from the remote infrastructure. B. It executes all Spark compute on your local hardware and exclusively accesses remote files. C. It proxies Spark commands from your local development environment over to the remote cluster. D. It mirrors a complete remote cluster environment locally onto the engineer's workstation. The correct answer is C. It proxies Spark commands from your local development environment over to the remote cluster. Why this is the correct answer. Databricks Connect works by decoupling the client application, running on your local machine, from the Spark driver and executors, running on the remote Databricks cluster. The proxy mechanism. When you write and execute PySpark code locally, Databricks Connect parses your code, builds a logical execution plan, and proxies sends those Spark commands over an API connection to the remote cluster. Heavy lifting versus local outputs. The remote cluster handles a heavy data frame transformations, like joins, aggregations, and filtering, using its powerful cloud compute resources. When you call an action like .show or .collect, only the final, evaluated, and usually small subset of records is sent back across the proxy to be displayed locally in your terminal. Why the other options are incorrect. A is incorrect. There is no manual synchronization required. The data transfer happens automatically over the Databricks Connect connection when an action is triggered. B is incorrect. This describes a purely local Spark setup that merely reads remote storage, like mounting an S3 bucket or ADLS locally. Databricks Connect shifts the heavy compute away from your local machine. D is incorrect. It does not mirror or containerize the remote cluster environment locally. Your laptop doesn't need the massive RAM or CPU cores of the remote cluster to run the scripts. Q15. A data engineer is designing a Lakehouse architecture using the Medallion model to support Business intelligence dashboards. They want to understand how gold tables and silver tables relate to each other in terms of data transformation and analytical readiness. What describes a relationship between gold tables and silver tables? A. Gold tables tend to include aggregations more often than silver tables. B. Gold tables tend to hold data that is more valuable than silver tables. C. Gold tables tend to represent a less refined version of data compared to silver tables. D. Gold tables tend to contain data that is more truthful than silver tables. The correct answer is A. Gold tables tend to include aggregations more often than silver tables. Why this is the right choice? In a medallion architecture, data flows from raw ingestion to business-ready insights. Silver layer, cleaned and conformed, this layer acts as the enterprise's single source of truth. The data is validated, enriched, and structured into clean, granular tables, but it generally avoids heavy aggregation, so it can serve multiple downstream use cases. Gold layer, curated and business-ready, this layer is specifically optimized for business intelligence, BI, dashboards, and analytics. Because it is tailored to specific business needs or departments, it frequently utilizes aggregations, roll-ups, and business logic to ensure fast query performance for reporting tools. Why the other options don't fit? B is incorrect. Value is subjective. Silver tables hold the critical, granular foundational data that powers multiple gold tables. Both layers are highly valuable. C is incorrect. Gold tables are more refined, not less. D is incorrect. Both layers should be equally truthful and accurate. Silver ensures quality and consistency, while gold simply restructures that truth for specific analytical use cases. Q16. A data engineer is updating a Delta table that stores transactional records. To maintain data integrity, they want to write data into a Delta table while avoiding the writing of duplicate records during ingestion. The engineer is evaluating which command supports conditional logic to prevent duplication, which command should be used to write data into a Delta table while avoiding the writing of duplicate records. A. Drop. B. Insert. C. Merge. D. Append. The correct answer is C. Merge. Why this is the right choice? The merge statement, often referred to as an upsert, allows you to combine your incoming source data with an existing target Delta table based on a matching condition. To avoid duplicates during ingestion, you can specify conditional logic. When a match is found, you can choose to update the existing record or simply do nothing. When no match is found, you insert the new record. This ensures that if a transactional record already exists in the destination table, it won't be written a second time. Why the other options don't fit? A. Drop. This is a data definition language, DDL. Command used to completely delete a table or schema from the metastore, not to write or filter incoming data. B. Insert, and D. Append. Both of these operations blindly add incoming records to the table without checking existing data. If the incoming dataset contains records that are already in the table, they will write them anyway, resulting in duplicate entries. Q17. Your analytics team is tasked with delivering a time-sensitive dashboard that pulls fresh data every hour to reduce startup delays and ensure minimal latency during job execution. You're evaluating infrastructure options. In which situation would using cluster pools be the most effective solution? A. The report must support version control across multiple collaborators. B. The report must be executable by all stakeholders. C. The report must complete its refresh cycle with minimal delay. D. The report must produce identical results across repeated runs. The correct answer is C. The report must complete its refresh cycle with minimal delay. Why this is the right choice? Databricks cluster pools reduce cluster start and auto-scaling times by maintaining a collection of idle, ready-to-use virtual machine instances. When an hourly scheduled job kicks off, it can instantly acquire instances from the pool instead of waiting for the cloud provider to allocate, boot, and configure new virtual machines from scratch. This significantly eliminates cold start overhead, directly addressing the need for minimal delay in time-sensitive, hourly data refreshes. Why the other options don't fit? A is incorrect. Version control and multi-user collaboration are handled at the code level using Databricks Git folders, formerly repos, not cluster infrastructure. B is incorrect. Restricting or allowing stakeholder execution is a matter of access control lists, ACLs, and workspace permissions. D is incorrect. Reproducing identical results relies on data consistency mechanisms like Delta Lake's ACID compliance and time travel, and deterministic code, not instance preallocation. Q18. A data engineering team is experiencing delays when executing Databricks SQL queries because the SQL endpoint is not active at the time of submission. To improve responsiveness and reduce wait time for results, they want to adjust the endpoint configuration. What is the most effective way to address this issue? A. Enable the serverless feature and set the spot instance policy to reliability optimized for faster startup. B. Activate the auto stop setting to shut down the endpoint when idle. C. Increase the SQL endpoint's cluster size to boost compute capacity. D. Expand the upper limit of the SQL endpoint scaling range to allow more resources. The correct answer is A. Enable the serverless feature and set the spot instance policy to reliability optimized for faster startup. Why this is the right choice? When a Databricks SQL endpoint is inactive, stopped, and a query is submitted, a cold start delay occurs while the system allocates and initializes virtual machine infrastructure. Serverless SQL warehouses completely remove the classic startup delay by utilizing a pre-warmed, elastic pool of compute resources managed in the Databricks Cloud account. This brings startup times down from several minutes in Classic/Pro to just a few seconds. Setting the spot instance policy to reliability optimized ensures that the underlying infrastructure prioritizes acquiring stable, immediately available virtual machines to prevent any provisioning delays. Why the other options don't fit? B is incorrect. Activating AutoStop does the exact opposite. It automatically shuts the endpoint down when it sits idle. While great for reducing costs, it actually increases the chances that subsequent users will encounter an inactive endpoint and suffer a cold start delay. C and D are incorrect. Increasing the cluster size, e.g., from small to medium, or expanding the upper scaling limits increases the processing capacity, throughput, once the endpoint is fully running. However, it does not fix or reduce the initial start wait time when the endpoint is inactive. Q19. A data engineer is updating a customer analytics table in Databricks. The incoming dataset may contain new records as well as updates to existing ones. To avoid inserting duplicate entries and ensure accurate updates, which command should the engineer choose? Merge into or insert into? A. Use the command when the data needs to be moved to a different location. B. Use the command when the destination table is stored externally. C. Use the command when the source table is no longer needed after the operation. D. Use the command when the destination table must avoid duplicate entries. The correct answer is D. Use the command when the destination table must avoid duplicate entries. Why this is the right choice? The scenario describes an upsert problem, handling incoming data that contains a mix of new records, which need to be inserted, and updates to existing records, which need to replace old entries. Merge into is the correct choice here because it allows you to specify a matching condition like source.customer_ID equals target.customer_ID. It uses conditional logic, when matched then update and when not matched then insert, to ensure existing rows are updated in place, completely preventing the creation of duplicate entries. Insert into, by contrast, blindly appends every incoming row to the table, which will result in duplicate entries for customers that already existed. Why the other options don't fit? A and B are incorrect. The choice between merge and insert is determined by your data duplication and conditional logic needs, not by whether data is moving to a different or external storage location. C is incorrect. Whether or not you delete the source staging table after the operation has no bearing on which SQL command you use to write the data. Q20. A data architect is reviewing the organization's fragmented data infrastructure Where different teams use separate systems for reporting, analytics, and machine learning to improve efficiency and reduce complexity, they're looking for a solution that can simplify and unify siloed data architectures across these specialized use cases. Which of the following can be used to simplify and unify siloed data architectures that are specialized for specific use cases? A. None of these. B. Data lake. C. Data warehouse. D. Data lakehouse. The correct answer is D. Data lakehouse. Why this is the right choice? A data lakehouse is a modern architectural paradigm that directly addresses this exact fragmentation. It combines the best elements of both worlds: the structured data management, ACID transactions, and high-performance querying of a data warehouse, ideal for traditional reporting and business intelligence. The low-cost, flexible, and scalable storage of a data lake, ideal for unstructured/semi-structured data used in big data analytics and machine learning. By unifying these capabilities into a single platform, using open table formats like Delta Lake, Iceberg, or Hoodie on top of cloud storage, it eliminates the need to maintain separate, siloed systems for different data teams. Why other options are less ideal for unification? B. Data lake. While great for storing raw data for machine learning, data lakes traditionally struggle with the fast query performance, concurrency, and strict schema enforcement required for corporate reporting and business intelligence (BI). C. Data warehouse. Excellent for reporting in SQL analytics, but it is too rigid, expensive, and poorly suited for storing the massive volumes of raw, unstructured data, like logs, images, or streaming data, needed for advanced machine learning models.